Language and Asphasias. Term test. 30% of the final grade office hour today 1 to 2. Similar format as test 1. 30 pints multiple choice, mainly textbook. 10 matching points, any material. 10 points diagram, any material. 50 points shorter/longer answer, any material. Bannock chapters 6, 8 and 9. Sachs chapters 1, 4, 8 and 9. Lectures 4, 5 and 6. Lecture outline. Neurological approaches, psychological approaches. Language impairments, aphasia. Non-fluent impairments. Fluent impairments. Psychological approaches. Phonology, syntax, and semantics. Combined approaches, imaging etc. Reading. The phonological route. The direct route. Right hemisphere contributions. Prosody, narrative and inference. Neurological approach to language. Paul Broca and Dan. Broca's patients, production impaired but comprehension relatively intact. Carl Wernick. 2 patients, fluent but nonsensical sounds, words, sentences. Neurological approach to language. Aphasia refers to a disorder of language apparent in speech, in writing, agraphia, or in reading, alexia, produced by injury to brain areas specialized for these functions. Disturbances of language due to severe intellectual impairment, to loss of sensory input, especially vision and hearing, or to paralysis or incoordination of the musculature of the mouth, called anarthria, or hand, writing, are not considered aphasic disturbances per se. Primary aphasia, due to problems with the language processing mechanisms. Secondary aphasia, due to memory impairments, attention disorders, or perceptual problems. Summary of symptoms: disorders of comprehension. Poor auditory comprehension. Poor visual comprehension. Disorders of production. Poor articulation. Word-finding deficit, anomia. Unintended words or phrases, paraphasia. Loss of grammar or syntax. Inability to repeat orally presented material. Low verbal fluency. Inability to write, agraphia. Loss of tone in voice, apraesidia. Classification of aphasias. 3 test parameters: spontaneous speech, auditory comprehension, and verbal repetition. 3 broad categories. Non-fluent aphasias. There are difficulties in articulating but relatively good auditory verbal comprehension, for example, Broca's severe, Broca's mild. Fluent aphasias. Fluent speech but difficulties either in auditory verbal comprehension or in the repetition of words, phrases, or sentences spoken by others, for example, Wernick's, or sensory aphasia, anomic. Pure aphasias. There are selective impairments in reading, writing, or the recognition of words, for example, agraphia, alexia without agraphia, non-fluent aphasia, Broca's aphasia, aka expressive aphasia. Non-fluent speech, short phrases, pauses, makes errors, repetitious errors in grammar, omits function words, verbs, telegraphic speech. Poor repetition. Somewhat good comprehension. Can be mild or severe. Non-fluent aphasia, Broca's aphasia. Associated with damage in the frontal lobe. Not due to damage to the motor strip. Broca's area, BA 44 and 45. Fluent aphasia, Wernick's aphasia. Problems in comprehending speech, input or reception of language. Fluent meaningless speech. Word salad. Paraphasias, errors in producing specific words. Semantic paraphrasias, substituting words similar in meaning. Bun, house. Phonemic paraphrasias, substituting words similar in sound. House, mouse. Neologisms, non-words, galump. Deficit in categorization of sounds, for example, L versus R. Poor repetition. Impairment in writing. Fluent aphasia, wernixophasia. Associated with damage to the temporal lobe near Heschel's gyrus, primary auditory cortex. Fluent aphasia, conduction aphasia. Carl Wernicke suggested that there could be another aphasia that could be produced by damage to connections between Broca's and Wernicke's areas. Difficulty in repeating what was just heard, no repetition or paraphasias. Comprehension and production intact. Developing a model of language in the brain. Concept center, place where meanings are stored. Transcortical motor aphasia. Transcortical motor, comprehension and repetition are preserved, however the speech is non-fluent. Transcortical sensory aphasia. Transcortical sensory, repetition is preserved, speech is fluent but comprehension is impaired. Fluent aphasia, anomic aphasia. Amnesic aphasia. Comprehends speech. Fluent speech. Repetition okay. Cannot name objects. Naming problems tend to be a result of temporal damage, whereas verb finding problems tend to be a result of left frontal damage. What is this object called? I know what it does. You use it to anchor a ship. Fluent aphasia, anomic aphasia. First of all, this is falling down, just about, and is gonna fall down and they're both getting something to eat. But the trouble is this is gonna let go and they're both gonna fall down. I can't see well enough, but I believe that she will have some food that's not good for you and she's to get some for her, too. And that you get it there because they shouldn't do up there and get it unless you tell them that they could have it. And so this falling down and for sure there's one they're going to for food and this didn't come out right. There, the stuff that's, good for, it's not good for you but you love, HW intentionally smacks lips. And so they've, see that. I can't see whether it's in there or not. I think she's saying, I want 2 or 3, I want 1, I think so, and so she's gonna get this one for sure, it's gonna fall down. Global aphasia associated with extensive left hemisphere damage. Deficits in comprehension and production of language. Summary of aphasias. Type of aphasia: spontaneous speech paraphasias. Comprehension. Repetition. Naming. Broca's. Non-fluent. Good. Poor. Global. Transcortical motor. Wernicke's aphasia. Fluent. Plus. Transcortical sensory. Conduction. Anomic. Psychological perspective. Psycholinguists do not break down language into production and comprehension. According to psycholinguists, language has 3 components: phonology, syntax and semantics. Psychological perspective. Phonology. Phonology, sounds that compose language and the rules that govern their combination. Phoneme is the smallest unit of sound that can signal meaning, for example, /b/in/bat/and/p/in/pate/. Allophones are different representations of the same phoneme, for example, /p/in/pill/versus/spill/. Persons with Broca's aphasia have difficulty producing the correct allophone of a phoneme, lack of fine control, mispronunciation of a phoneme. Individuals with Wernicke's aphasia do not make these mistakes. They produce the wrong phoneme. For example, they might substitute /p/ for /b/. Phoneme substitution. Psychological perspective. Syntax. Syntax, the admissible combinations of words or phrases and sentences, called grammar in popular usage. Individuals with damage to anterior parts of the brain, for example, Broca's aphasia, show difficulties with syntax. Broca's patients often omit function words, for example, verbs. This is not only a problem in production. They have problem comprehending syntax as well. The lion killed the leopard. Who is alive? Broca's patients have problem with syntax and do not know the answer to this question. Wernicke's aphasia patients usually do not have difficulties with syntax. Their sentences contain syntactic markers, i.e., verb endings, prepositions, auxiliary verbs. Psychological perspective. Semantics. Semantics, meaning of words and word combinations. Sentences might have different syntactic structure yet have approximately the same meaning. Immediately after the class I started to study. As soon as the class was over I initiated my studying. Wernicke's aphasia is characterized by semantic deficits, understanding the meaning of words. This deficit is seen in written language as well. Token test. Point to the yellow square and then blue circle. Broca's aphasia patients have relatively intact semantic processing. Problems arise when syntax is important, for example, place the blue circle on top of the big red square. Psychological perspective summary. Location of damage. Phonemes. Syntax. Semantics. Anterior. For example, Broca's aphasia. Difficulty in producing particular phonemes. Impaired. Unimpaired, unless syntax important. Posterior. For example, Wernicke's aphasia. Phoneme substitutions. Relatively unimpaired. Summary of neurological and psychological perspectives. Anterior regions, i.e., the frontal lobe, is important for speech production and syntax. Posterior regions, i.e., temporal and parietal lobe, is important for comprehension and semantic processing. Converging evidence. WADA test. Left hemisphere role in language. WADA technique using sodium aminobarbital. Crossed aphasia, aphasia arising from right hemisphere damage. Speech representation, percent. Handedness. Hash of cases. Left. Bilateral. Right. 140. 96%. 0%. 4%. 122. 70%. 15%. Converging evidence imaging studies. Peterson et al. Study. Passively presented words, or pseudo-words, either visually or orally to passive subjects, a passive task. Another condition involved subjects repeating words, an output task. Final task, an association task, involved subjects suggesting a use for the object named by target word, for example, cake. Converging evidence imaging studies. Peterson et al. Results. Passive task, viewing, activation in primary and secondary visual areas. Passive task, hearing, activation in secondary hearing area. Repeating task, activation of motor and sensory facial areas, supplementary speech area, right cerebellum and insular cortex. An association task, generating verbs, was associated with activation of the frontal lobe and posterior temporal cortex, also the anterior cingulate and cerebellum. Converging evidence imaging studies. Binder et al. Presented subjects with either tones, 500 or 750 Hz, or meaningful words, nouns designating animals. Also had a rest condition. Subtracted method revealed that large portions of the brain are involved in language processing. Converging Evidence Imaging Studies. Damasio et al. Measured activation associated with naming persons, animals and tools, semantic processing, converging evidence imaging studies, summary. Imaging data does support evidence that classical language areas, for example, Broca's and Wernicke's areas, are important for language. However, many other parts of the brain are also important for language functions. It is more likely that the brain is organized in units devoted to phonology, syntax and semantics rather than speaking, repeating and listening, for example, classical model. Neurological basis for visual language processing. Brain damage can produce alexia or agraphia. Alexia, inability to read. Agraphia, inability to write. Is there a double dissociation? Neurological basis for visual language processing, reading. Two roots whereby visually presented words are linked to meaning. Phonological route to reading, see the word, sound it out, understand the meaning. Grapheme to phoneme. Direct route, printed words are directly linked to meaning, useful to reading irregular words, such as yacht or kernel or pint. Reading. Two roots neuropsychological evidence. Damage to direct route. Surface alexia. Reading by sound. Cannot recognize words but can understand them by using grapheme to phoneme relations. Words can be understood if they are sounded out. Regular words are read normally, home or dome. Irregular words are not read properly, yacht, det, ache or key. Patients read lace as lake, come as coom. These patients can pronounce regular non-words, for example, glimay. Overgeneralization of rules. Does every language have surface dyslexia? Reading. Two roots neuropsychological evidence. Damage to phonological route. Phonological alexia. Patients do not have problem reading previously learned words, regular or irregular, as they are using the direct route. Patients extract the meaning directly from the visual form of the word. They have problems reading new words both regular or irregular. Intact direct route is not enough because they do have the connection between the visual form of the word and meaning. Reading. Two roots neuropsychological evidence. Deep alexia, related to phonological alexia. Key feature are semantic errors. Patients read semantically related words in place of the word they are trying to read. Merry as Christmas. Cow as horse. Food store as grocery store. Function words are very difficult for these patients. Concrete words better than abstract words. Unable to read non-words. Reading. Other deficits attentional dyslexia. Reading individual letters or words is normal. Unable to read if more than one type of stimulus is present in the visual field. Reading. Other deficits neglect dyslexia. Patient misreads or omits the initial, left neglect, or terminal, right neglect, parts of the words. Left neglect. Let wet. Clock. Anyone one. Right neglect. Breaking break. Registrar registration. Tongue to. Processing of non-Indo-European languages, Kana and Kanji. Not all languages use a phonetic alphabet. Japanese have two writing systems. Kana is syllabic and sound-based, phonologic route. Kanji is logographic. Each symbol stands for a concept. No relationship between visual representation and pronunciation. Direct route. Double dissociation, right hemisphere contribution to language. Since Broca, the left hemisphere's role in language has been central and right hemisphere has viewed as non-language hemisphere. In split brain patients, language can emerge from the right hemisphere. The right hemisphere cannot produce speech. use phone to grapheme correspondence or understand syntax. The right hemisphere can extract basic meaning.